Okay, welcome. I'm going to show you guys now how to graph a trig function, and we're going to do it really carefully. Shows up a lot on the regions, really important to do. So here we go. It says, on the axes below, make an appropriate scale and graph exactly one cycle of the trig function this. So this is where I pulled the problems from in the original main lesson. But I'm going to show you just how to do it here because it's a little tricky. So 6 cos 5x, it's a cosine function, which means that it looks like this. I'll sketch it out. Positive cosine function. So we're going to plot 5 points. Okay. It's got an amplitude. Well, we could do CAB, right? P. It's got a midline of 0. Okay, because there's nothing here. It's not shifted up or down. It's got an amplitude of 6. Its frequency is 5, which means its period, we'll call BP equals 2 pi. So this gives us 5p equals 2 pi. Divide by 5, which means p equals 2 pi over 5. And with all of this information, we can graph it. So first thing that we want to do is label the x-axis. So we need to have, just follow me on this, a 2 pi over 5, okay? Right, this is what I meant by it was tricky. I'm going to make this y-axis go up by 2, 3. I'll make it go up by 1. So you set the x and y axis labels and then click done. Okay, now you have this point, 2 pi over 5. You have to decide where you want to put this point. Okay, I suggest just leaving it out here at the end. And now, like I said before, we're going to plot, okay, 1, 2, 3, 4, 5 different points. And if we've got, oh, cool, there's like a little different ones I can do. 3, 4, 5, fun. All right, so now if we've got, let's see how many dots, spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That means each one of these sections, okay, is going to be, each one of these points is going to be 5 away from the other point. So this is going to give us 5, 10, 15, 20. That's important. It says move the x-axis scale and plot 5 points for the cycle. Okay, 6 cos 5x. It's a cosine function. I'm going to go up to 6 and plot a point right there. Then I'm going to go over 5. 1, 2, 3, 4, 5. And then this goes down to 0. There's my second point. Over 5, 3, 4, 5, and down 6. Again, over 5, 1, 2, 3, 4, 5, and then up 6. 6 again is the amplitude, and then over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. Okay, once you get that, just check it. We've got a midline of 0, amplitude of 6. and it looks pretty good. So I'm going to hit submit and click yes. And I did get it. Now let me show you a different way that that could have went. So I'm going to go back to show question, and I'm going to reset it. We know that this was, again, I already forgot the period was 2 pi over 5, I believe. Yeah, so the period was 2 pi over 5. Recall that. So period equaled 2 pi over 5. Okay, so I'm going to label again the x-axis, I'm sorry, the y-axis going up by 1. The x-axis, you want this to have 2 pi over 5. And I'll hit done. And now I'll show you a different way that you could have graphed this. You could have went maybe 1, 2, 3, 4, 5, okay, and plotted the points. So you would have went up 1, 2, 3, 4, 5, 6. Two, 2, 3, 4, 5. So what I mean by this is tricky. It's not hard to graph, it's just sometimes the delta math doesn't work as well as I would like it. And 1, done. Try a new problem. Okay, so we've got 4 sine 5x. So that means that it's going to also be 2 pi over 5. I just want to do this quickly so you see. I'll go up 1, hit done. And what I could have done is dragged this in 1, 2, 3, 4, 5. And now plot my sine function. Starts on 0. Goes over 1, up 4, then over 1, down 4, over 1, down 4. Oh, you can see I didn't plot that one correctly, so let me reset it. So I'm going to plot my first point, my second point. I'm going to go 0, then 4, then 0, then -4, and then 0. So 1, 2, 3, 4. I want to only have to go over 4. So 0, 4, 0, -4, back to 0. Okay, and we hit submit. Okay, purpose for that is you could plot it so that it's spread out, or you can plot it so that it's really tight, or you could plot it so that it's spread out even further. It doesn't matter as long as you label the end point of one cycle of the graph. I'm going to go back and see if I can find maybe a harder one of these. Okay, so here we've got a sine function. Let's do this. Clear. We've got a c value of -12. So I'm going to go down by 2's. got an amplitude of 2. This looks like the type of problem where the scaling is the issue. B value is 1/3. That means P is going to be 2 pi divided by 1/3, which is 2 pi times 3/1, or 6 pi. So that's what I need to write here. 6 pi. Okay, here I'm going to have this go up and down by 2. And I graph this. Now I'll pull this in. Let's say I have to graph how many points? 1, up, down, 4, 5 points. So maybe I can go over by 2, or maybe by 3. Every 3, I'll plot a point. So 1, 2, 3, I'll plot a point. Then 1, 2, 3, 1, 2, 3, 1, 2, 3. So that'll get me out to 12. It is a sine function starting all the way down here at -12. Let me clear this out. -12, I go over 1, 2, 3, and then up 2. Up 2 is just 1 unit. 1, 2, 3, then down. 1, 2, 3, then down. 1, 2, 3, and then back up. Hopefully this is it. Seems legit. Okay. All right, so they're tricky. The trickiest part is, look, I did it just like they did, is I think using the delta math, but you have to be really precise when it comes to these types of problems. So again, if you have any trouble with these, we will, I'll answer any of those questions in a live webinar later.